In this video, we're going to look at a couple of applications of systems of equations in two variables. So here Sarah has a home business making large decorative candles. The cost of materials is $3.50 per candle, and her rent and utilities average $900 per month. So that's all of her business expenses. And then her candles sell for $9.50 each. So the question is, how many candles must be sold each month for her to break even? So we have her monthly expenses, and we have her monthly or her revenue per candle. Um, and so the question is then, she wants to at least break even, hopefully make some money, but she at least doesn't want to lose money. So if we let X be the number of candles that she sells in a month, that's what we're trying to find. And then we can write down an equation for the cost of running her business for a month and an equation for the revenue. So let's start with the cost. The cost is going to be $3.50 per candle. So 350 times however many candles she sells, which we're calling X. And then each month she also pays $900 for the other expenses. So that's her monthly cost for X candles. Her monthly revenue for X candles is going to be $9.50 times however many she sells. And she wants to break even, so she wants her cost and revenue to at least be the same. And so this is a system of two equations, and we can use the substitution method pretty easily here because they're both solved for y already. So we can just take the 950x and plug it into the other equation for y essentially. And then we can solve for x. So we'll subtract 350x from each side. That gives us 6x equals 900. And if we divide both sides by 6, x is 150. I always like to make sure I'm answering the question. In a word problem, it says how many candles. That was the value of x we determined. And so she needs to sell 150 candles each month just to break even. All right, here a theater has 500 seats. Tickets are going to be $40 per adult and $15 per child. How many of each type of ticket must be sold to have a revenue of this much? So when you're choosing your variables, always look at what you're trying to find. How many of each type of ticket? So this time there's two pieces of information we're looking for. How many adult tickets and how many child tickets? So I'm going to call X the number of adult tickets, and I'm going to let Y be the number of child tickets. Now there's two numbers, there's a price given for each one. There's two key numbers here that are going to help us set up our two equations. We know how many seats there are, and we know how much revenue we want to make. So those are each going to be a separate equation. So let's start with the seats. We're going to sell X adults tickets and Y children tickets, and we only have 500 seats. So the number of adults coming plus the number of children coming can't be more than 500. We like it to be equal because we're trying to sell out the theater. So number of adult tickets plus the number of child tickets should be 500. And then the revenue, that's where the price per ticket is going to come in because we want to make this much money. We make $40 per adult ticket, so 40 times X tells us how much revenue we make from the adults, and $15 per child ticket, so 15 times Y tells us how much revenue we make from the children tickets, and we want all of that to total 15,625. And so we can then solve this system using either substitution or addition. I'm just going to change it up and use addition since we did substitution for the last one. So I'm going to take that first equation and I'm going to try and eliminate the y's. So I'm going to multiply that first equation by negative 15. That way the y's will add to 0. And so we have then negative 15x minus 15y equals negative 7,500. And I'm going to keep the second equation exactly how it was. And then negative 15 plus 40 is 25, so we have 25x. Negative 15y plus 15y is 0, that was the goal. And then when we add the right side, we get 8,125. Divide both sides by 25. X is 325. We always want to make sure we're answering the question. We're asked how many of each type of ticket, so we found one of our two numbers that we're looking for. We want 325 adult tickets. But we also want to know how many children tickets. So we can substitute the 325 for x. I'm going to use that really nice equation there, x plus y equals 500. That was just from the fact that we have 500 seats. So if we have 325 adults, subtract that from 500, then we'll have room for 175 children.